Hello students, we are going to start the last chapter of wave optics as per our syllabus, that is the diffraction of light. Now let us see what is diffraction. Till now, whatever you have studied in optics tells us that light travels in a straight line. However, this is true. But if the size of the obstacle or aperture is small, means comparable to the wavelength of light, then there is a departure from the straight line propagation. Means then it is observed that the object, that light bends. Light does not travel in straight line, but light bends. When will light bend? If the aperture, if there is an aperture in the path of the light, that is the opening in the path of the light, or there is any such obstacle which is in the shape of the whose wavelength is comparable to the wavelength of light, then we will see that light does not travel in straight line, and in the place of shadow we will find some light coming there. For example, imagine this is a small slit whose width is comparable to the width of light. Let us, if we can imagine that this slit is about the wavelength of the light. Okay, in that case, these are the parallel plane wave fronts, and when they are coming out, then these slits, then every point on the slit, as per the Huygens principle, is behaving like a source of secondary wavelets, and these secondary wavelets are coming out, and these are the secondary wave fronts. These are the spherical wave fronts. These are the secondary and these are the direction of the rays. So here we can see that this and this point, if we keep a screen here, then we will see that in the place of where we expect shadow, we will get some light. Okay, why? Because light is diffracting. Diffraction means the bending of light around the corners of sharp edges, or passing of light through the aperture whose size is comparable to the wavelength of the light. Now we are going to study about the Fraunhofer diffraction. See, this you can see, this is a diffraction pattern. Now suppose, and we will observe this diffraction pattern as a central bright spot and then some dark and bright fringes, But unlike what we have seen in interference, these bright and dark fringes are of different wavelength. They are of different width. Okay, you can see this is a much brighter and these are the lesser. These are of different width. Now, let us see the pattern. This is a source of light and a lens is placed at and this source of light is at the focus of this lens, so that these two rays become parallel and the rays are emerging from the slit. This is a slit whose a very short slit, a very small slit whose wavelength can be compared to the wavelength of light, whose length can be compared to whose width of the slit can be compared as the wavelength of light. Now what to do? This is another lens to focus the rays more clearly. Now suppose the rays which are meeting here are in the same phase. There is no path difference. The rays which are from A to B, from A and B, the rays which are meeting here are in the same phase. There is no path difference. So there is a constructive interference. So there is a constructive interference, and we will see a central bright fringe, a broad central bright fringe. But some of the rays are diffracted from this slit at an angle theta, and they reach the P, and there is the point P. These rays are diffracted through an angle theta and they reach the point P. Now what happens at this point P, as you can see here, let us consider that this AB is E and this angle is theta. So the rays which are going from A to P and B to P, they have a path difference of bk. which is the perpendicular. So AK is actually perpendicular drawn to the AK is the perpendicular drawn to BK. So this is the perpendicular. So if I here there is any one point, so the path difference between this will be BK. Okay, so AP and KP are equal and the path difference is BK, and which is equal to E sin theta. E is what? Width of the slit. V is what? Width of the slit, which is comparable to the wavelength of light. Now, so this we have done. Now let us consider that, now let us divide this slit in two parts. Okay, as I told you, this, let us first we have considered that the length of the slit is lambda, and then we have divided the slit into two parts, so that the rays from one part, suppose there are 100 points. Okay, let us imagine that there are 100 points between A and B. So we are dividing into two parts, 1 to 50, 51 to 100. Now one point from this part, and suppose point number 1 and point number 51, whenever they will meet, there will be a path difference of lambda by 2. Okay. Similarly, when the point number 2 and point number 52, then also path difference lambda by 2. So if you take any one point from here and the corresponding point from here, they will meet and at the path difference of lambda by 2. So as the path difference at this point is lambda by 2, so it is obvious that there will be a destructive interference and we will get the first minima, that is the dark spot, the first dark spot. Okay. So why we are getting the first dark spot? Because the rays that are reaching here are of the wavelength, are of the path difference lambda by 2. So we have considered AB as lambda, then BK will be what? E sin theta, that is lambda sin theta. Okay, so that will be lambda by sin theta. So from here we can say sin theta, E sin theta is equal to lambda, or E sin theta is equal to, so this condition gives us the first position of the minimum. Okay, so the additional minima are obtained by the relation E sin theta is equal to plus minus m lambda. So m can be 1, then that will give the position of the first minima. If m is 2, that will give you the position of second minima. If m is 3, that will give you the first position of third minima. From this and from this formula we can get the position of different minima. This plus minus sign means that these minima are produced. As you can see in the figure, this is the principal maxima and these minima are produced on either side, on both sides of the principal maxima. So that is why the first plus minus signs are given. Now, so this was the condition for minima. Similarly, so what was the condition? That E sin theta is equal to a multiple of lambda. Now, so the central part is a bright spot, no doubt, but we have also some decreasing order, some other maxima also whose intensities are much less than the principal maxima. So what is the condition for formation of mth secondary maximum? So this is called the primary maximum and these are called the secondary maximum, and this is called the first minimum, this is called the second minimum, and so on. So E sin theta, so the condition for the formation of m secondary maximum is that E sin theta should be a odd multiple of lambda by 2. E sin theta should be odd multiple of lambda by 2. Then we will have this is the condition for secondary maximum. And if E sin theta equal to lambda, or you can say even multiple of lambda by 2, then that is the condition for minimum. Okay. Now width is what? Same as we have done in the case that the width is equal to, okay, though this is the formula for the width, so 2 theta is equal to lambda by E. Okay, so this theta is the angular spread of the central maximum, this theta, okay, is equal to lambda by E. E is what? E is actually the width of the slit. Okay. So please, interference and diffraction. What is the difference? Interference is due to superposition of light waves coming from two sources. You have seen in YDSE, we have seen there are two slits. Here, the diffraction is due to the interference of secondary wavelets coming from different points from the same slit or same wave. Means these are coming from the different points of the same wavefront. Acha, point number 2. Interference fringes may or may not be of the same width. Here we can see the interference patterns are on may or may not be of the same width, but diffraction fringes are never of the same width. Okay, you can see this is broader, shorter, different intensity, different width. Okay, and study the remaining portion. So this is the part of the chapter. So please go through the video and study from the book. Have a nice day.